Good morning, everyone. My name is Twinkle, and today we'll be discussing a topic that is nuclear force and binding energy. But before starting, let's just go around a few basic terms. We know that everything in this universe is made up of fundamental quantities which are known as atoms, and atoms can be further not classified, but we can say that atom is further made up of protons, neutrons, and electrons. The proton and the neutrons reside inside the nucleus, and because of this they are also known as nucleons. So it's more like the members of the nucleus. The particles which reside inside the nucleus are known as nucleons. Since the proton and the neutron reside inside the nucleus of the atom, that's why they are known as the nucleons. Also, these electrons revolve around this nucleus. So if this is the nucleus where positively charged protons and I am like denoting the electron by zero. I am denoting the neutron by zero charge. So if nucleus is shown as this, then the electrons are revolving around this nucleus in the circular orbits. Just okay. Now it's quite obvious that protons carry positive charge, neutrons carry zero charge, like they do not carry any kind of charge, while the electron carry negative charge. Electron carries the negative charge. Now we also know that the like charges repel each other while the unlike charges attract each other. This implies that if I am placing a proton and an electron side by side, they will attract each other. However, if there is a system that comprises of two protons or two electrons, it will basically both of the particles will repel each other. So now the question arises, if two like charges just like this, if two like charges repel each other, then what is the reason behind protons being held together in the nucleus? We know that atom on a whole is electrically neutral. That is because the positive charge of the nucleus is like balanced by the negative charge of the electron. But I am asking that if positive charges repel each other, what is the reason as to why in the nucleus all these protons are held together? They must be repelling each other. Then why does not the nucleus collapse? What is the reason as to nucleus is still existing? So this is where the nuclear force comes into existence. But before moving forward, it was earlier assumed that protons inside the nucleus are held together by the force known as the gravitational force. However, it was found that the magnitude of the repulsive force was very much higher than that of the gravitational force. I'll just write down the numerical value for you as well. It was found out that magnitude of repulsive force was very much greater than the gravitational force. In fact, this repulsive force, I am denoting it by R, Fr. The ratio of this repulsive force with gravitational force was found out to be 10 power 36 times, implying that two protons inside the nucleus are repelling each other with a force which is 10 power 36 times stronger than the gravitational force trying to hold them together. This implied that our observation or our concept of thinking that gravitational force could be a reason as to how protons are held inside the nucleus is incorrect. It is wrong to say it would be wrong to say that gravitational force is the reason as to why the protons are held inside the nucleus. This is where the nuclear force kicks in. With the discovery of nuclear force, it was explained as to how, despite the positive charges, the protons are actually held inside the nucleus. If I want to put it in simple terms, nuclear force is nothing but it is the force that actually holds the different type of particles together inside the nucleus. And now by different particles I mean the protons as well as the neutrons. Now, in order to understand the nuclear force in better terms, we'll study about the properties of the nuclear force. So, if I talk about the properties, the very first property is nuclear force is the strongest force of the nature. What does this means? In actual practice, we have four types of forces in nature. The very first is the nuclear force. We have electromagnetic force, the gravitational force, and the weak force. The strongest force among all these four is the nuclear force. Number two is that nuclear force is attractive in nature. Nuclear force is always attractive in nature, but there is an exception. The exception is that if the particles are brought together up to a distance less than zero point 0.5 Fermi meters, sorry, zero point 0.5 into 10 power 15 meters, or I can simply write it as 0.5 Fermi because we know that there are 10 power minus 15, sorry, this would be minus 15, because we know that there are 10 power minus 15 meters in 1 Fermi. So if the particles, if two protons are brought up to a distance less than this, then this nuclear force will also have a component of the repulsive force. This means that in general the nuclear force is attractive in nature, but if the distance between the particle is reduced lesser than that of this value, they will start repelling each other. Number 3 is the short range force. By short range force, what we mean is, this is quite obvious from the second point also, nuclear force works only up to a range of 10 power minus 15 meters. It itself indicates that is very short range up to which the nuclear force acts. However, if we actually want to go into the numerical value, nuclear force acts up to a distance of 4.2 into 10 power minus 15 meters. If the distance between the particle is more than that of 4.2 into 10 power minus 15 meters, the nuclear force exerting between two particles will be negligible. These were the three important properties. After that, the fourth property is the saturated forces. By saturated forces, okay, let's just take into consideration the carbon nuclei. If I'm talking about the carbon nuclei, there are 6 protons, right? Like Z equals to 6 and 12 equals to atomic mass is 12. In carbon nuclei, there are 6 protons and 6 electrons, and 12 minus 6 corresponds to 6 neutrons. This is clear to you, right? Like if you want to calculate the number of neutrons in a nuclei, what we do is we just simply subtract the atomic number from the mass number. That is basically what gives you the number of neutrons. So by saturated forces, what do I want to convey is that, okay, you have 6 protons in the nuclei. Now let's just take this one proton into consideration. The nuclear force experienced by this proton is not because of all the other protons, but only because of the protons which are present in the neighborhood. Like the protons which are in the neighborhood of like these three. Those protons which are in the neighborhood of this particular proton will be exerting the nuclear force. Right? Now next is charge independent. Nuclear forces are charge independent. By charge independent, what we mean that nuclear force acting between two protons is exactly equivalent to the nuclear force acting between two neutrons, which is equal to the nuclear force acting between a proton and a neutron. What we are trying to say here is that there is no such condition as that the charge, irrespective of what the charge of the particle is, nuclear force acting between the charged particle will always be doing, like between the charged particle and the, like between the uncharged particles also, it will always be same. Next is nuclear forces are spin dependent. I'll just erase the other points as well. By spin dependence, what do we understand? What we want to say is that the nuclear force acting between two nucleons, by nucleons he means the protons and the neutrons. It could be anything, because since protons and neutrons reside inside the nucleus, so we call them nucleons collectively. So the nuclear force between two nucleons having parallel spin will be more than the configuration where the nucleons are present in the, like where the neutrons are present with the like anti-parallel spin. So if the spin is parallel, the nuclear force will be more. If the spins are anti-parallel of those two nucleons, the magnitude of nuclear force will be lesser. Next is non-central forces. By non-central force, what he wants to say is that the nuclear force acting between two nucleons never acts along the line joining the center of two bodies. Like this is okay. I previously mentioned you that two protons are repelling each other with some force. So that repulsive force is actually because of the Coulombic repulsive force, or the Coulombic repulsion. What do we call it? Yes, Coulombic repulsion is what we call it. So Coulombic repulsion. Just a minute. Coulombic repulsion or Coulombic repulsive force is the force that acts along the line joining the center of two bodies. However, nuclear force is different from the Coulombic repulsive force. It is attractive in nature. Also, it does not act along the line joining the center of two bodies, or you can say two charged particles. The last property of the nuclear force is quite tricky. It is of a bit higher level, but it is one of the important properties that we need to understand if we actually want to dig deeper into what the nuclear force exactly is. That is, nuclear forces are exchange forces. Now, by exchange forces, what does it mean? Okay. See, I already told you that nuclear forces are not the forces that acts along the line joining the center of two bodies. Then how does the interaction between the question arises, how does the nuclear interaction or the interaction due to nuclear force act between the two particles? See, whenever two protons are interacting because of the nuclear force, there is exchange of three particles between them. It could be either pi 0, pi plus, or pi minus. And these exchange particles are known as pions. I won't be going very much deeper into this, but you can think of this of a similar of a like by considering a simple example. Think of two dogs who have a single bone. Now both of the dogs are basically fighting to get that bone, right? So it is not like that there is no struggle between the dogs or dogs are trying to play with that bone. Both of the dogs are actually trying to get that bone because there is one single bone and they are fighting because of that bone. But that bone is what is keeping the both of the dogs together. Now think of those two dogs as two protons and these pions, one of these pions as the bone. Both of these protons, no matter, I am not like I am not completely keeping this out of place, the fact that these two protons are are not exerting repulsive force on each other. They are actually repelling each other, but because of the bone for which they are fighting, that bone is these pion. When the both of these protons are trying to exchange, are trying to get that bone or basically that pion, and that pion is responsible for keeping both of these protons together. So that struggle is also a kind of repulsive force, but because of the fact that it is keeping the protons together, that is where the purpose of nuclear force fills, that irrespective of all the repulsive forces, it simply holds the protons for the for the time until or unless the nucleus is bombarded by some external force. So that was all about the nuclear force and its properties. And now for binding energy, we will be discussing that topic in our next video. Thank you.